Hello, my name is Zhu Haoxiang. I am a student of Master of Business Analytics in Nanyang Technology University. Today I will use both Python and R to build some simple models to predict whether a person suffers from diabetes. Let's first check our dataset. Here we can see there are 8 features and the class are tested positive and tested negative. And we can say we have 773 observations. So that's a data set we have, and let's turn to our code. Before we start our programming, I have prepared 2 files for our model. The first one is accuracy. I defined a function named getAccuracy that will return the accuracy of our model. The second one is plotcm. It contains a function that will plot the confusion matrix to us. So now let's start our data cleaning. First import packages. Wait a second. Okay, and then import dataset. And then start our data cleaning. Because there might be some wrong values in our data, so first we need to check our data types. And we can say for diastolic blood pressure, age, and the class, they are object, and others, they are integers or float. So there might be some wrong values in those 3 columns. And first, let's check diastolic blood pressure. I try to convert all the value in this column to a float type and see if there is any error value. Yes, there is one bin. It's a string. We don't know what it represents, so we just to numeric all the values, and this value will be converted to a non-value. And then for age, let's check. Yeah, for these 2 we can understand what it represents, so we just replace them with integers. And then for class, first we need to check if all the values in the class column are tested negative or tested positive. And we can see there is one that is tested negative. Maybe someone just want to say tested negative, so we know what it represents, and we replace all the values to 0 and 1, so we can prepare them for our classification. And at last we drop the non-value in our data sets, because here we will have non-values. So run it. And then for outliers, let's check at first. So we can see number of times pregnant. These 2, it seems impossible. And plasma glucose concentration at 2 hours. 0, it seems impossible that the value is 0. And diastolic blood pressure, 0, also impossible, and these are too low. And more than 300, also wrong. So this, okay. These are all right. And for age, we don't want to research too much about whether a kid will suffer from diabetes. And also here 135 seems impossible. So now we need to fix those problems, and we just replace some outliers with their mean values. So let's do it. And for those ages, we just drop this rows, drop these observations, and finally box plot to check. Seems good. So now we have cleaned our data sets, and we will save the data frame to CSV file. Okay, great. Let's check. Yeah, here we have a new CSV file named diabetes final. So now we will build 3 modules by Python. First, logistic regression. Import packages. Wait a second. Great. Import our dataset and split the dataset into train test and a test set. Here I set the test size to be 20%, and we will standardize our data by using min-max scalar. Here, let's do it, and begin to build our logistic model. Okay, and we have make a prediction, and then we tested the accuracy. The accuracy is good, 79.22%, and we have 32 values that are wrongly predicted. 23 are actually positive, and 9 are actually negative. We want to improve our model, and first we need to output the statistic magnitude, and here we can say for x3, x4, x5, and x8 their p-value is not significant, so we need to drop those features. And here we drop them, and then split our data and standardize our data. And here we rebuild our model and print the result. The accuracy remains at 79.22%. It did not change, but here we can say our model is more concise, which is a good thing. So that's a logistic regression in Python. And then we will do decision tree by Python. First, import packages. The previous steps are the same. Import dataset, split dataset, and then we began to build our decision tree. And simple tree, we will see our accuracy is 72.08%, and there are 43 values wrongly predicted. And we can plot our tree to visualize our tree. Sorry. Here we can say the tree is too complex. We don't want that's complicated tree. It will have overfitting problems. So we need to purine our tree. And here we use cost complexity purine path, and get every train scores and the test scores for each alpha. And we will print out the best alpha and plot the accuracy versus alpha for training and testing sets. Here we can see the best CCP alpha, and the plot here, the best alpha is here, and we will use this best alpha in our new model, and we can see the accuracy improves to 81.17%, and the wrongly predicted values are only 29. So the number decreased a lot, and we can visualize our tree. Yes, here we can say the tree is more concise. It is very good. And then we will use Python to do neural network, import packages, and using TensorFlow. Wait a second. Done. And then import dataset and split datasets, and build our model. For our datasets, the dataset of diabetes are well researched, and the model for diabetes usually has 2 hidden layers. For first hidden layer, we have 12 nodes, and the activation function is ReLU. And for the second layer, we have 8 nodes, and the activation function remains at ReLU. And for the output layer, the activation function, we use sigmoid. And for epochs, we set it to 150, and for batch size 10. And here we run our model. Consumes time. Okay, and here we get the accuracy is 79.87%, and 31 are the number of wrongly predicted value are 31. So that's our neural network by Python. And then we will use R to build 3 models simply. And the first one is logistic regression, and we import our packages and read CSV file and split datasets. Here we also set the split ratio to be 0.8, and train set data test set, and standardize our data. Here we use method center when pre-processing, and then we build our logistic model. Here we set threshold to be 0.5, larger than that, positive, lower, negative, and we can get the accuracy is 77.9%, and the number of values wrongly predicted are 38. We also want to improve the model in R. So first, here we can say for those coefficients, they are not significant, so we need to drop these features. Here, select what we want, what feature we want, and split data, standardize data, rebuild our model, and here we can see the accuracy drop to 71.9%, and the number of values wrongly predicted increased to 43. So the accuracy drops, and but we can see the model is more concise. So that's logistic regression in R, and we clear here, remove objects, and now turn to decision tree in R. First, import packages. Good. Read CSV file, split data, normalize data, and we began to build the tree. First, we set the CP to be 0 and plot our tree. We can see the tree is very complicated, complex tree. So we maybe run the prediction and get the accuracy is 64%, and the number of values wrongly predicted is 62. Here we began to purify our tree. First, we plot CP, so we can get here. The CP, when the CP value is 0.021, the model has a best result. So we set, we set the CP here and plot our new tree. Here we can see it is more concise. Yes, and what about the accuracy? Yes, the accuracy improves to 68%, and now the number of values wrongly predicted decreased to 55. So that's decision tree by R. And now we clear, remove, clear, and now we turn to neural network by R. Also import packages first, read file, split data set, standardized data, and now we began to build our network. Like what we did in Python, we set 2 hidden layers here, and the first has 12 nodes and the second one 8 nodes, so we can visualize our neural network here. So it's easily visualized in R, and we can see that's our network. And we get our prediction, and the accuracy is 68%, and the 55 value, the number of values wrongly predicted is 55. So we have built logistic regression, decision tree, and a neural network by both Python and R. Thank you for your watching.